Welcome to the Metrology lecture series. In the present video, we will discuss the measurement of backlash and lead of gear. Let's see what is backlash. Backlash is the small gap between two meshing gear teeth. So backlash is the amount by which the tooth space is larger than the thickness of the mating tooth. In general, backlash is needed between the two mating tooth. Let's see what is the need of this backlash. A tight fit between gears is not good because it can be causes for the noise, overheating, power loss, lubrication failure, bearing overload, and the early gear failure. In this regard, a small amount of backlash is necessary for smooth operation. So if tooth thickness equal to the tooth space mean there is the no backlash. So there is the zero backlash. If it is the zero backlash mean there is the no clearance exist. Even a small error in mounting will be causes of jamming. So teeth are made slightly thinner to allow the smooth motion. There are the two types of backlash is exist between the mating tooth. One is the circumferential backlash. It is measured along the pitch circle. And the second one is the normal backlash. A normal backlash is measured perpendicular to the tooth surface. So let's see the circumferential backlash. So it is the gap between two meshing gear teeth measured along the pitch circle. So let's fix the one gear and now rotate the another gear slightly. Then distance it moves along the pitch circle before contact occurs is called as the circumferential backlash. And it is measured an arc length which is not a straight distance. So let's see the second type of the backlash, that is the normal backlash. Normal backlash is the shortest distance of this gap which is measured perpendicular to the tooth surface. So there are the relationship between the normal backlash and the circumferential backlash. So that is the normal backlash equal to circular backlash into the cos of pressure angle. So in general, a dial gauge is usually employed to measure the backlash. Let's see the procedure. So first step is we have to lock the one gear, which means fix the one gear so it cannot rotate at all. In general, in a gearbox, we can lock the input shaft. And second step is set up the dial indicator. So which has to be attached the magnetic base to the rigid surface and place the dial tip on the face of the free gear. Then you have to position it at the pitch circle. Then ensure the tip is perpendicular to the tooth surface. And next third step is zero the dial. So you have to adjust the dial indicator so it reads 0 before taking measurements. And next step is measure the movement. So generally you have to rotate the free gear in one direction until it should be touch the teeth. In this condition, you have to note down the reading. Then once again you have to rotate it in the opposite direction until the contact. So once again you have to note down the reading. Then backlash equal to the total movement or difference between the two readings. So same procedure you have to repeat at different positions, which mean rotate the both gear together to a new position. Then once again you have to lock again and repeat the measurement. So in general you have to take the 3 to 4 readings around the gear. Next we will discuss the measurement of lead. So first we have to see the what is the lead. Lead is the distance a helix which moves along the axis in one full rotation. For spur gears, lead means how straight the tooth is across its face width. So in general, lead equal to axial movement of helix in one complete turn. So let's see the what is the lead importance of the lead. Lead ensure the proper contact between the gear and pinion. If lead is not correct, then contact will uneven. Then it will be result in wear and noise will be increase. So let's see the procedure how to measure the lead. So first we have to the gear is mounted on a machine. Then a measuring probe which has to be touches the tooth at the pitch circle. Then probe moves parallel to the gear axis. Then probe is connected to a dial gauge. In this condition, as probe moves, the dial gauge shows the deviation. The total reading on the dial gauge which is equal to the lead error. So this is the measurement of the backlash and the lead, and thank you.